Question 3. Sketch the graph of y equals tan theta, where theta is an element of negative 2 pi, comma 0. Again, I'm just trying to get you used to the different ways we can write stuff, but it all means the same thing. Theta is just a variable, so all good. It's just like having x there, or t, or whatever. So it's the same thing as we're doing for these last ones. Obviously, this time we have y instead, but that's pretty common for graphs, so not a massive difference. And then theta just needs to be part of the group. That's what that kind of symbol means. It needs to be part of the group that goes between negative 2 pi and 0. So again, theta just needs to be between negative 2 pi and 0. That's all that this stuff is saying. So essentially, it's a different question because we're doing tan, right? But in terms of that notation, it's the same as the last ones. Seeing that these last ones were pretty, short in the horizontal to like the left and right direction, let's put this more in the center. And I know that tan does those crazy kind of shapes. If you remember back to tan, like we have kind of this shape. Remember, it goes up to, essentially it goes up to positive infinity and down to negative infinity. And so I'm going to make the y-axis a bit taller this time. 4, 1, 2, 3, 4. And then we'll go a little bit past it to put our arrows in. Okay. X-axis here. We don't need much of the positive x-axis. Let's just put that there. And the straightest line in the world, like that. Okay. We only need to go up to negative 2 pi. Let's make this negative 2 pi. And we'll mark in our quarters. Even though, as we'll see in a second, tan's a little bit different. So we might not, we might need a bit more than these quarters here just to, work out what's going on. But we'll put them in. I think it'll be helpful. Okay, tan of 0. We're going to start over here and work our way backwards. Tan of 0 is 0, because if you have a unit circle, I'll draw a quick one here. Remember, tan you can think of as the gradient, okay? So this line, when we're at an angle of 0, how steep is it? If we go across, how much are we going up or down? None. And so it's not steep at all, it's 0. So tan of 0 is 0. Now, as we make our way down here, like that, like this, how steep are these lines? As we go from left to right, do we go up or down? We go down. And so the gradient of this line is negative, so we're going to be coming down this way. What happens when we get to negative pi on 2? How steep is the line? It doesn't kind of make sense. You could say like it's infinitely steep, or you could say it's negatively infinitely steep, right? And another way is like it's undefined, because as you go across, how much you go up and down, you don't go across at all, and so that's why it's undefined, because it doesn't make any sense to say. But you could say it's infinitely steep. That is also okay. So we need to kind of make our way down here. If you remember the shape of tan, it's kind of like this squiggly line. It can help to think about the fact that at pi on 4, the gradient is 1. And because we're pointing, like we have a negative gradient, so it's going to be negative 1. So I can think about here at pi on 4, or negative pi on 4, we have 1. So there's no, big rules about this. I'm just going to say here is going to be my negative 1, which means here is going to be my positive 1. That's important for the cos and sine. Like you need to mark in the 1s and the negative 1s because they're part of the key points. But for tan, it's not as important, so you can kind of put them wherever you want. Like you could have put negative 1 down here or down here. I probably wouldn't put it that far because it's harder to show the shape of it. Maybe even here could be negative 1. few different options. I'm going to put it here. Okay, now I need to make my way over to this with a bit of a curve. And then I'm going to keep that curve going. And I'm going to dodge the negative pi on 2 because it's an asymptote. So I'm going to just go like that. Nice. Now, after negative pi on 2, what happens? Well, we keep going this way. So this is where our lines would be at. How steep is this? Kind of steep, but is it positive or negative, basically? It's going to be positive because as this line, as we go across, it's getting hard to see on here, but as we go across, we go up for this line here. Okay, so we're going to have a positive gradient. It's going to start out super steep. I'll draw a new one because we're getting crowded. Here we were super steep negative, and here we're super steep, but now we're positive. So we jump all the way up to here, and we're going to make our way down. Let's mark in our halfway point and a positive 1, because we're going to need to get through there. So we'll come down from here, through there, and like that. Not bad. What happens? So, and then we get all the way over to here, and again we've got a negative. Sorry, we have a gradient of 0 at negative pi because we're completely flat. And now we actually repeat ourselves because remember, once we keep going on with our angle, so we come all the way around here, and we're going to keep going like this. Because we're just looking at the gradient of the line, it's actually the same as what happened over here. Like the gradient of this part is the same as the gradient of this part. And so although our like unit circle line is more in here, just this part here I'm trying to highlight, just this, because we're looking at the gradient, we can look at the whole thing. And so we're going to start repeating ourselves. And so it's going to do this again, but over here. Let's mark in our halfway point roughly and our negative 1. So I need to go through there, a bit of a slant. Yep. And then dodge the negative 3 pi on 2. So we'll draw in an asymptote line there. And then just dodge it like that. That looks good. And then again, we're still repeating because now we're coming up around here. We'd hit there and get our undefined negative infinity, positive infinity thing. And then as we keep coming around, now we have a really big positive gradient because as we go from left to right, we go up. It's going to start out really steep. So we're going to come from up here and go down to there. So marking our little halfway where we're going to hit the gradient of 1 and make our way down from positive infinity through there, hit the negative 2 pi because I'll draw another unit circle. Don't be afraid to draw lots of little unit circles as part of your working. If it's an exam, obviously I would put this on my working paper and not, pollute my answer. But yeah, don't be afraid to draw lots of little unit circles. So from negative 3 pi on 2, we kept going like this, getting less steep, but we're positive. Less steep, less steep, less steep. So we're coming down here. We'll hit our 1. We'll hit the gradient of 1 around there. And then we'll keep going until we get completely flat at the rotation of negative 2 pi. And that will be our value of 0. And so we're done. These ones we do want to mark in. So if you drew them like too lightly, I kind of drew them lightly here, but they're part of it. So we do want them to be there. These ones are kind of optional. And so they're fine as they are. We just don't need to mark them particularly. All right, that's that one done.